Hi, good morning. Today we are going to see about our logic gates. Under that unit, minimization techniques and logic gates. In that subject are digital principles and computer organization. In previous video, we have discussed about what is minterm, what is max term, what is SOP and POS, and what are the laws that to be used for minimization techniques and basics number systems. These are discussed in previous video. Now we are going to discuss about the logic gates. These are the different types of logic gates: and, nor, and, or, not, NAND, nor, XOR, XNOR. These are the basic logic gates. What is logic gate? Logic gate is an idealized or physical electronic device which is used for implementing a Boolean function, a logical operation function, or one or more binary input that produces a single binary output. These are the symbols of and, NAND, or, NOR, not, XOR, and XNOR. These are the symbols for representing the logic gates. Then these are the classification of logic gates, like basic logic gates, universal logic gates, and other logic gates. Basic logic gates are and, not, or. These are the basic logic gates. NAND and not or universal logic gates, and XOR, XNOR. These are the other logic gates. NAND and NOR are universal logic gates because any gates can be designed by using NAND and NOR. So it is called as universal logic gates. Next is AND gate. In AND gate, we are having a two input and one output. This is the AND function. It will perform an AND function. The output will be positive when both the input, that means the input 1 and the input 2 are positive. It will be true. X equal to A and B. If the both and functions for both the input will be 1, then only it will be output, it will give the output as 1, remaining part it will be 0. For OR gate, in Boolean algebra, the OR function is equivalent of addition, so its output state represents the addition of its input. In Boolean algebra, the OR function is represented by a plus sign. So for two input OR gate, the Boolean equation is given as Q equal to A plus B. That is, Q equals either A or B. In that way, this is the symbol for OR gate. Here we are having a truth table. In that, if either our input is 1, that output will be 1. If only if only both the inputs are 0, then in that case only the output will be 0. But in case both the inputs are 1, then only the output will be 1. In remaining case, the output will be 0. In NOT gate, the NOT function is not a decision making logic gate like that of AND or OR gates, but instead it is used to invert or complement a digital signal. In other words, its output state will always be the opposite of the input state. If A is 0, then output will be 1. If A is 1, the output will be 0. NAND gate. The term NAND gate is a contraction of NOT and implies an AND function with an complemented output. The output will be high when any of the input is low, and the output will be low when both the inputs are high. This operation is opposite to that of an AND gate. NAND is just an opposite of AND gate. In AND gate, both the input are 1, then only it will be the output will be 1. In NAND gates, it's just opposite of 1. If both the inputs are 1, then output will be 0. The remaining case, the output will be 1. Next one is NOR gate. The term NOR is a contraction of not or and implies an OR function which is just a complemented output. The output will be low when any of the input is high, and the output will be high when both the inputs are low. This operation is just opposite to that of OR gate. In OR gate, any of the input is high, the output will be high. But in NOR case, any of the input is high, the output will be 0. If both the output will be low, then both the input will be low, then the output will be high. Universal gates. NAND and NOR gates are used to generate and NOR function. Any logic functions can be implemented using NOR and NAND gates. So it is called as any function can be implemented by using NAND and NOR gates. So it is called universal gates. This is an XOR gate. This is an symbol of XOR function. Here we are having either any of the input is high or low, then the output will be high. If both the input will be same, the output will be low. This is the case that we are using in XOR gate. This is the output that we are getting in XOR gate. Here we are having, for XOR gate, we are having a dot b complement plus b complement, sorry, a plus a complement dot b. This is the symbol, this is the formula for a XOR b. We are also having an XNOR gate, that is just opposite for XOR gate, and the complement of XOR is the XNOR gate. Boolean expression using logic gates, we are having a three input OR gates, like A, B, C. We are having given input to the OR gate. We are getting output as A plus B plus C, and complemented functions of A, B, and C is A and B is given to OR gate. Then C is directly given to OR gate. Then we got output as A complement plus B complement plus C, and A and C are directly given. B is complemented to OR gate. Then we are getting A plus B complement plus C. These three outputs are given to the AND gate, so that we get A plus B plus C star A complement plus B complement plus C star A plus B complement plus C. In that assessments, what we are going to discuss, what we are discussed in the slides are what are the universal gates, why it is called so, and draw the symbols and truth table of NOT gate and AND gate, and draw the symbol of XOR gate and explains its truth table. Thank you.